in this problem, we're doing A/B testing. So we have our two scenarios. We have scenario scenario A and the scenario B. And the way we assign users to these treatments, the algorithm we use to randomly assign the users is the following. So the algorithm is first user gets assigned randomly. So we randomly pick between treatment A and treatment B and assign that treatment to the first user. Then for the nth user, if the trial, or let's write it this way rather, if the trial for the nth user is a success, so if the trial for nth user is a success, keep the same treatment for the n+1th user. So use the same treatment for the next user, for n+1st user. Otherwise, switch the treatment. So we can imagine that treatments A and B are two versions of a website, and success is whether a user clicks in a particular part of the website. So we start first by assigning the very first user randomly to either version of those websites, either version A or version B. And if the user clicks on, and let's say the user gets assigned to version A. Now if the user clicks on that part of the website, then for the second user, we're going to assign again version A of the website. But if the first user does not click in that part of the website, in other words, the trial fails, then for the next user, we're going to assign version B of the website. So we're going to stick with the same treatment or the same version of a website as long as the trials are successful, or as long as the users keep clicking in that part of the website. And so the problem also makes a couple of definitions. So first, let's define the following. So P sub n is going to be the probability of success on the nth trial. So this is probability of success on nth trial. We're also going to have A sub n, and this is the probability that treatment A is assigned on the nth trial. Probability that treatment A is assigned on nth trial. Little a is the probability of success for treatment A. Probability of success for treatment A. And little b is the probability of success for treatment B. Note that little a and little b would be unknowns in real life, because if we knew which one of them was more successful, we'd go with that version of the website. So little a and little b are unknown in real life, hence why we do A/B testing. So part A of the problem asks us to find two things. First, we need to show that probability of P sub n, so little p sub n, equals A minus B times A sub n plus B. So let's first show this. So what is little p sub n? Well, that is the probability that we have success on nth trial. How could we register a success on nth trial? Well, that can happen in two ways. We're implicitly using the law of total probability here. So that can happen in two ways. Either the nth trial was assigned to treatment A, and we had success under treatment A, or the nth trial was assigned to treatment B, and we had success under treatment B. And so simplifying this expression, we get A minus B times A sub n plus B. which is exactly what we wanted to show. So the b here, this is exactly what we wanted to show. The second thing we'd like to show is that a sub n plus 1 equals a plus b minus 1 times a sub n plus 1 minus b. So again, what is a sub n plus 1? That is the probability that the treatment A is assigned on the n plus first trial. So again, implicitly using the law of total probability, how could that have happened? How can the n plus 1th trial be assigned to treatment A? Well, that can happen is, the one way that can happen is if the nth trial, the previous trial, was assigned to treatment A, and it was a success, or the nth trial was assigned to treatment B, and it was a failure, so that the n plus first trial switched treatments. So it was a failure, 1 minus B. And now, distributing and simplifying, we get exactly the results we want, which is a sub n times a plus b minus 1 plus 1 minus b. And so we've proven the two equations. Now, in part B, we're asked to show that p sub n plus 1 equals a plus b minus 1 times p sub n plus a plus b minus 2ab. So we want to show that there's this recursive relationship between the probability of success on a given trial and the probability of success on the previous trial. There's this recursive relationship between these probabilities of success. And we're going to use several things here. So first, from part A, we're going to use this result here from part A to rewrite probability p sub n plus 1 as a minus b times a sub n plus 1 plus b. So we have already an expression for a sub n plus 1 that we showed, which is this expression here. So we can now substitute that expression into the a sub n plus 1 here, and what we get is a minus b times, now we substitute that expression in there, and so we get a plus b minus 1 times a sub n plus 1 minus b plus b. And we also can use this expression here to solve it for a sub n and substitute it for a sub n here. So we get, in total, we get a minus b times a plus b minus 1 multiplied by, now solving this expression for a sub n, we get, solving this for a sub n, we get that a sub n equals p sub n minus b divided by a minus b. And now substituting it for a sub n here, we get p sub n minus b over a minus b plus 1 minus b plus b. And now we're ready to simplify. So once we distribute everything out and simplify, we get that p sub n plus 1 equals a plus b minus 1 times p sub n plus a plus b minus 2ab, as desired, as we wanted to show. And so again, we substituted expressions into one another until we had p sub n plus 1 on the left, and we had this p sub n on the right. So we had an expression that showed a relationship between p sub n plus 1 and p sub n, and at that point we were ready to distribute and simplify these expressions, and after that simplification we got our desired result. And now part C of the problem says we want to use the result we got in part B to find the long-run probability of success, meaning the limit as n goes to infinity of p sub n. So what we can do is, let's denote this, let's call this little p. So let's write the expression we got from part B. So p sub n plus 1 equals a plus b minus 1 times p sub n plus a plus b minus 2ab. So now we're going to take the limit of both sides here. So the limit as n goes to infinity, p sub n plus 1 equals a plus b minus 1. So that's a constant, a times b plus 1, that's a plus b minus 1, that's a constant. So we can factor it out from the limit. So this is the limit n goes to infinity p sub n. And the rest of the expression is also constant, it doesn't change with the limit, so we can just write it as is. So notice that that the limit as n goes to infinity of p sub n plus 1 is equal to the limit as n goes to infinity of p sub n. Because n is just going to infinity, so n plus 1 is really the same as n. When we take them to infinity, they grow at the same rate. So these are the these expressions are the same, and we denoted them as p. So we're going to replace p here. So p equals a plus b minus 1 times p plus a plus b minus 2ab. And now we're ready to solve this expression for p, and we get that p equals a plus b minus 2ab over 2 minus a plus b. And so this here is the long-running probability of success.